thanks to everybody, and thanks to the organizer for this opportunity. This talk is made in Chicago, so we are not importing anything. This is not from Silicon Valley or from anywhere, just right from Chicago.
Can you turn your microphone over?
Here.
Can you clip it on your? Can you clip it right here? Slip.
Right here. Yeah, thank you. So I said that this talk is made in Chicago, and I'm also a big data solution architect who is living in Chicago. So I have over 4 years of experience, and I had the chance to work on over a dozen of big data projects. And I would like to share some of my learnings, recent learnings about this transitioning from of the compute models from Hadoop MapReduce to Spark. And transitioning means that still things are happening, so are still in the making. So that's me, that's a picture of me. Yeah, here we go. Maybe this is in line with what we just heard from the audience in relation to when it comes to big data and use case, whatever. So when you see this diagram, you don't see the name of any of the Hadoop vendor, right? Do you see any? No, right? So this is an abstraction of a big data stack. And I would like to start with my presentation with this one, and I invite you to stare at it, and we'll discuss it in a few minutes. And this will be something that will be one of the main things that we'll keep using throughout this talk. So now in this big data stack, if you consider Hadoop, which I think most of you guys are familiar with, may I see a show of hands of who already familiar with Hadoop, who used Hadoop? Yeah, so pretty much most of the audience. May I see a show of hands who is maybe not used Spark, who is familiar with the concept of Spark? So that's good, actually. So we expect a good discussion tonight, I guess. So so when we say this is a big data stack, so if you start with the bottom layer, so we are talking here about the storage layer, right? So it can when we are talking about Hadoop, change your storage by HDFS, Hadoop Distributed File System. Change your database by HBase, Hadoop database, or MapRDB, which is API compatible with HBase. And to your right, you see streams, right? So you might see data coming to your data storage layer through Kafka or through Flume, right? Now, if we go further to the up layer in red, so we are seeing the resource management. So when we are talking about Hadoop, maybe it comes to mind YARN, yet another resource negotiator, right? I will keep focusing on Hadoop, and then we will talk about Spark and other framework. Now, if you go up, execution engine, obviously in Hadoop we are having MapReduce, so Hadoop MapReduce. So on top of this, you see different type of tools or applications that we can use. For example, when it comes to stream processing or streaming, you can think about Apache Storm. You can think in the Hadoop world, right? You can think about the one from Twitter, Samsa. So when it comes to scripting language, think about Hive, Pig. When it comes to application, think about cascading, think about Crunch. When it comes to machine learning, think about Mahout or Mahat, depends how you pronounce it. When you come to graph processing, this is Giraffe in this case. So this is an example of a Hadoop, of a big data stack, which is in this case Hadoop. Now, as we are seeing now, the market or these computing models are evolving, and we are seeing more options, right? So when it comes to Spark, this is the latest one. not really the latest one, but the one which is currently have the most of the buzz. As you will see in a few minutes, Apache Spark is not the latest. Again, here, when it comes to the storage, before talking about Spark, let me tell you that Spark is coming from another big data stack, which is called, sorry for my pronunciation, I hope I pronounce it the right way, is BDAS, not something else, BDAS, BDAS, B-D-A-S. So if somebody knows what BDAS stands for? Yes, please. Anybody knows what BDAS stands for? Yes, please. Excellent, excellent. So BDAS stands for the Berkeley Data Analytics Stack. So that's where Spark is coming from. It started at the University of Berkeley from AMP lab, and that's where Spark is born. But so if we consider that stack and the storage layer, we have something which is called tachyon. So not HDFS. So that's in the storage layer. When it comes to database, you have LinkDB. When it comes to resource management, you have Mesos. Execution engine, you have Spark. Streaming processing, you have Spark streaming. Machine learning, you have MLlib, machine learning library. Graph processing, you have GraphX. When it comes to scripting language application, basically you are using the native Spark API. So we are seeing still again the same. When we abstract this stack, we are seeing they are very similar, right? So that's the idea here. And what we will be actually talking about, that they are not like exclusive. So that's maybe one of the main takeaways already from my talk. At the end, you will be see. So it's not. You might hear in the news, right? Spark is. They are mostly using these terms. Spark is ending Hadoop. Really, this is a title of news which comes recently for good, and this is for one known and respected actually company out there. I won't give the name of the company, but that's reading the news. So as technical people, actually, maybe in my case, actually, I'm kind of like really overwhelmed with all this news and reading about which is kind of like sometimes misleading, and they are really not giving good service to the industry, actually. So I'm not blaming anybody. So my talk here is trying to stay away from marketing fluff, from politics, and this is a pure technical talk. And again, as Mike mentioned to the audience, this is independent, vendor-independent talk, and we are trying to stay away from all this marketing and politics. I hope you find this interesting. So, and this is the basis of our talk, to think always about this stack in terms of Hadoop, in terms of Spark. How about now another big data stack, which came recently from, not recently actually, it's old, it's since 2009. Did anybody heard about Apache Flink? Flink, F-L-I-N-K. One or two in the audience? So that's not surprising actually, but my prediction or my analysis of what's going in the market, this will pick up actually in a very good way in the very near future. This is another actually big data stack, which is very compatible with Hadoop, but using a different approach. It's close to the type of MPP type of processing. If you continue staring at this big data stack, I hope by this time you are not getting bored. So you can have the storage as HDFS, but the resource management, you can have Yarn or Mesos, so either one of them. Execution engine, you have Flink execution engine. When it comes to streaming, there is Flink streaming. They have also their own library when it comes to graphs. So what we are seeing here, there is type of evolution out there from different big data stacks, starting from Hadoop to going to Spark, going to Flink. And as I said, this is the main things that we need to keep in mind, and I promise this will make this presentation, this talk more interesting. Now I can talk about the agenda of this. I started with this diagram of the big data stack. Now it will be easier for you to say, keep that stack in mind. So we are talking about evolution, right? Already touched on that. We will be talking about the transition, right? So if you are using a specific big data stack, let's say Hadoop, and you might be able to use the new big data stack such as Spark, and we say how this is happening concretely in this case, from Hadoop to Spark. And with all modesty, there is not a single talk or presentation or blog or article which touched on that. And as we will see in the, I'm kind of saying myself, but we will see in a few minutes. Also, we'll be talking about integration. So say you are using already Hadoop, big data stack, and now you are using Spark. You are not throwing away all your investment. We'll see that's how this is happening. We will also touch about the subject of alternatives. So the architecture itself of all of them is kind of like open, and you can swap component, and you'll see how you can almost like mix and match. And then we will touch about the subject of complementarity. So this means what we are saying here, this is not either or type of approach. It's not either use this one or you don't use or use the other one. I will show that in many cases they complement each other and they work together. And at the end, I propose my own key takeaways that might be not different from yours, and that will be open the discussion for what we have. Not necessarily Q&A. It will be discussion. It can be any suggestion, any enhancement coming from you guys. So here we go. Evolution of compute model. So that's. So as you see, we are moving from left to right. And the left we have the Hadoop MapReduce. So everybody knows that it's basically batch type of processing. We are moving from batch processing to TES. Anybody familiar with TES? A show of hands, please. Not that many, and I can understand. We are moving now from TES to another big data processing stack, which is Spark. So you see batch, interactive, near real time. Unfortunately, there is a lot of confusion going on. You will see a lot of articles, blogs, whatever, people telling you about real-time analytics in Spark. There is no such thing in Spark, real-time analytics. There isn't. You move now, you are seeing evolution actually to another stack, which is Apache Flink. Nobody is paying me to say that, but that might take over actually in the future. That not only support batch, but also interactive. So now you see that the three of them, they have batch and interactive. But what this Apache Flink has in extra is that it supports real time, not near real time, true real time. And also it supports iterative type of processing. I did not put iterative in under Spark, although technically it's possible, but it's not supported natively. So that's a big difference for me. That's not coming out of the box that the Spark supports iterative type of processing. Any questions so far, please? Yes, please.
What do you mean by iterative processing? Because Spark does support machine learning library, right?
Yeah, excellent question. Actually, yes. I will repeat it again. Spark supports iterative type of processing, obviously. If you are processing data and you cache it, and you can continue working on it. But this guy, this Apache Flink, they support iterative processing as native operator. They have operator which do iteration. So that's different approach. So that's kind of like why I did not put it here. So for me, it's a differentiator. So it's kind of like when it comes to Hadoop MapReduce, it's basically batch, but you can force it to do interactive type of processing. That's what Tez is doing. It's nothing but the enhancement of Apache MapReduce. Any other question, please, before we move to the next section? Yes, please.
How do you compare Storm with the Flay in real time?
Excellent. Yeah, Storm is a different is framework on its own, right? And it's a real-time processing, right? So I did not put it under any one of them here. So because here I'm talking about what these big data stacks support out of the box. What are their features, right? But obviously you can take Storm and you can run it on Hadoop, but Hadoop itself doesn't support real time. I hope I'm explaining the difference. Yes, please. So it's another tool which supports real-time processing. So it's not native support from the stack itself. So obviously here I did not touch on MapReduce 1, so I think we moved a long time away from there. So this is, that's when it comes to evolution of these compute models. I will promise that I won't be reading from the slides. They are here for your, for the sake of having something a reference for you. So you are exempted from taking notes, and later when the organizer will share the presentation, it will be easy to go and check and follow what I'm claiming or seeing like references to it. So here, very quickly, briefly, actually, we will touch on every single one of these big data stacks to see in concrete way this evolution, right? So when we talk about Hadoop MapReduce, it's basically batch processing. The main thing, actually, limitation is in the API, right? On the model itself, not every problem can be actually modeled as MapReduce. Unfortunately, actually, when you see like even big presentation, whatever, I will avoid to even share names. They will say limitation of MapReduce. It doesn't support, is not suitable for machine learning. Obviously, it's not, all right? So if you are having type of like interactive type of expect results, so your approach is wrong. That's the wrong tool from the beginning, right? So here, what you are saying here, so it's mainly for batch processing. You extend it with the UDF, user-defined function, as you saw in Hive and Peak. The difficulty of the MapReduce is reflected in the number of tools and on top of MapReduce. So that's kind of like how I can put it. So you see Hive, Peak, Cascading, Crunch. So all this, lot of this framework, simply because MapReduce is kind of like the assembly language of big data. So that's the reason. And you end up actually using many tools. What's interesting here, actually, Tez in Hindi, it means speed. Although I'm not from India, but I searched that. So that's what's interesting. So for every single computing model or execution engine, we will share how it's branding itself, and then we will share what we think is a differentiator, right? So here it's branding itself as a project, building an application framework which allows for a complex direct ASIC DAG of task of processing data. It's currently built atop Yarn. So it doesn't tell much, actually. But let me tell you, actually, it was built to make Hive and Peak faster. That's basically, yeah. As simple as this. Obviously, it's more generalized than MapReduce. And still it's batch. And now we are forcing it to become interactive. And it's getting there slowly, but surely. So that's what it is for Tez compared to MapReduce. So now it's supported batch and interactive. When we say interactive, it's that ability to query, for example, data through Hive and get back results in like human time, right? So not in milliseconds, but that's basically it, because there is already overhead of even running a simple query. Now, when it comes to Spark, so Spark is branding itself as a fast and general engine for large-scale data processing. So that's how this tool is branding itself. But let me tell you, this is incorrect, actually. because Spark is more than that. So we will continue hearing that in presentation, you name it, and Hadoop Summit, and everywhere, right? So Spark is not confined to a tool which is fast and general purpose engine. No, that's not the case, right? So it's more than that. Can somebody from the audience say why we can claim that it's not just simply like an engine? Yes, please. Anybody? Any volunteer? Yes, please. Any volunteer for sharing his opinion why this the way Spark is branding itself? I won't say incorrect, but is incomplete. Yes, please.
It also has application,
Excellent.
streaming, graph, machine learning.
Yeah, exactly. So that's simple, right? So it's not just the runtime, right? It's the runtime and it's the API, and on top of the API is also these libraries, right? If somebody used the Spring framework in the past, you might do the parallel, right? So you cannot say like Spring framework or Spring is a dependency injection framework and you stop. So indeed, it's the I framework, and also you have other library on top of it. So that's kind of like the parallel. So obviously here, think about it always as two things, right? That runtime, that engine. And when we say fast, it's not always the case. It depends on your data and it depends on use case, right? By the way, everyone is claiming that he's 100 times faster than MapReduce. So poor MapReduce, you will go to the literature of tests, they will tell you 100% faster. You go, clearly, literally, you go to the documentation of Spark, they will tell you from page 1, we are 100 times faster. I assure you, you go to Apache Flink, he will tell you 100 times faster, right? So this is nonsense, really. As a technical person, this is really nonsense. When you say a tool is 100 times faster than another tool, I mean, it doesn't make any sense. Because it depends on the context, it depends on your use case, it depends on your data, it depends on your configuration, it depends on your hardware, it depends on your setup, it depends on a lot of things, right? So that's not true. So that's more for marketing. I don't agree with that. That's my humble opinion. And this talk is vendor independent, vendor free. So I'm free here. I'm talking as just technical guy. Nobody's paying me or anything to say something in particular, right? So, but just for you, for us technical people, that 100 times is pure marketing fluff. So anyway, so that's my take on it. Somebody can challenge it, I can explain in details why, but I can assure you that every single one is using that same fluff 100 times faster. Anyway, so maybe one thing specific about Apache Spark, and here now you see how this is kind of like a demarcation or something from Tails and from MapReduce, the aspect of in-memory. So that's the thing. The aspect of in-memory and this RDD, which is the magic behind that speed, which is happening, it depends on the use case. So that's about Spark. Now how about this Flink? Yeah, Flink in German means nimble, swift, speedy. Another thing in common for all these big data stacks is that everybody is talking about speed, remember? Not just they claim 100 times faster, but also in their name, right? Tez means fast in Hindi, right? Spark means, and they write it right from their page 1, right? Blasting speed, whatever, blasting fast, right? So we can show you what they said. Lightning fast speed, that's a page in the Apache Spark webpage. Now when it comes to Flink, in German means speedy. Anyway, so these guys have things which are different from the other ones. And I foresee, and that's my responsibility, right? I foresee that this will become huge in the future, actually. It's solving many problems. Yes, please.
But where would you put Impala? Is that yet again another engine?
Yes, exactly. Yes, Impala is like this. You can say this is a special purpose built tool, right? So that's basically it, right? So it's only for querying data which is in HDFS. While these tools, they provide more than that, right? So that's the thing. Same thing for Storm, right? So Storm is built for specific purpose, right? to provide you with real-time data processing. So that's so here the difference here we are talking more about this main compute engine. So the main ones like as we said, Tez, Spark, and Flink. Yeah. Obviously, I did not introduce that here because it's built for specific purpose. Yes. So what's interesting here is solving some of the problems that Apache Spark has already, right? Many people are complaining about out of memory. These guys figure a way to fix it. And also there is optimization which is given for you out of the box, while in the Spark world, which is still kind of crafting almost, and that's the challenge when more than your word count when it comes to real implementation and real use case, you will somehow like suffer when it comes to tuning. This tool makes it less painful. So that's my take on this. So this is when it comes to the evolution. You know what? Here we are comparing apple with oranges, really. But I just put it like in this format, so it's easier for you to follow up, right? And we won't go by one by one. That's for your reference later, so you can go back to it. For example, if I pick libraries, right? Obviously, Hadoop MapReduce, besides the MapReduce API, you don't have that much. So, and you have to build this abstraction like Hive and Peak. While Spark, for example, have this library coming out of the box, which is a plus, and it's very for usability. It's something which is very good. For example, for Spark, it's very good that it supports many languages. This is already something big compared, for example, to Tez and Hadoop MapReduce, which are confined to Java. One of the big strengths of Spark that is written in Scala. Same thing for Flink, by the way. So that's what. So when it comes to ease of use, obviously Spark will be easier to program because when you learn that API, that main Spark native API, it will be easier now when you use the library for streaming or for machine learning. It ends up just a new algorithm that we are implemented and calls, and that's the main thing to take away from here, compared actually to Hadoop, for example, when you have to do a lot of UDF. So this is kind like things are already built in for you, available for you out of the box, and that's a huge difference. You don't need to go check them in open source, whatever, other project, whatever. It already comes with our 80 operator compared to your just map and reduce in the Hadoop MapReduce world. When it comes to Yarn integration, so people will tell you this is Yarn certified, whatever, I take my responsibility for this one. I did something, a very simple test, really. I will show it in a different slide and I will show you the query. I just went to the Jira of Apache Spark, and I searched for the word yarn, and I searched for the issue, and I classified them, just one simple query, and classified them by category. It turns to be a lot of issues out there are critical, and I stop here. As a technical person, if I go to a tool, and I find a lot of critical issues in it, so that's kind of like this, at least I will question, is this really ready? Now I forget about the marketing and somebody telling me certified and whatever, all this blah, blah, blah. So that's why I'm saying here, I forget about the marketing fluff, just as a technical guy. You tell me this tool is GI, right? General availability. Okay, fine. By the way, I did the same when Impala, you mentioned that, right? When Impala was announced, that is, I have nothing against any single vendor, by the way. But just this is an example. So in the blog, and this is available, Google for it, put Slim BOLTA-HOON, that's my name, and Impala, and you see it. I went to the blog and I commented, I say, no, it's not ready. It's not ready because there is blocking issue. As simple as this. This is open source, right? The code is available, right? The Jira is open. And you go and see blocking issue. So how come with blocking issue you tell me that the GI? Come on. So that's what it is. And by the way, I was told, okay, you know what, we are working in 1.1.1, blah, blah, blah. I stopped it. Okay, so that's the idea. You guys, you are technical people, you are smart enough to go write a single query that I will show, and you go to Jira and you see by yourself, find if something is ready or not ready. Any question, please? So far, so good. Let's continue. So when it comes to performance here, on purpose, I left it blank, and I said it in the beginning. I don't believe it is 100 whatever times faster, whatever. But I just put a command when it comes to Spark. It depends on if your data fits in memory or not, because they will tell you it will degrade gracefully. Gracefully will depend, and you do it on your own, and you figure out if it's always gracefully or not. So that's all I have about the performance. So we're done about the evolution. Maybe I need to speed up a little bit. So now we'll be talking about the transition. So you guys, and I see from the show of hands, many of you are using Hadoop, right? So you already invested the time and energy in learning Hadoop, right? And using many tools, right? And from this marketing, right? I think this Spark is the killing or whatever, or taking over, ending, whatever. So we get scared, right? Yes, please. Any question? No? Okay. Anyway, so just bear with me, actually. Yeah, I will show you. There is still time to learn actually this Apache Spark and to leverage your investment and the previous technology or tools that you used. And I will explain myself. So imagine you have an existing Hadoop project for some reason, right? Either somebody or a boss, whatever, heard about Spark and now he wants to use it, and people are telling you 100% times faster, whatever, blah, blah, blah. Okay, so now what do you do actually? So if you are convinced or you have a good reason to migrate your project from Hadoop to Spark, so I ask myself this simple question. What you do, right? So if you have a MapReduce code written in Java, right? From Scala or from Java, you can call this code. So almost no need of changing this code. So you can often reuse your mapper and reduce function that you already wrote. You can also go, if you have that luxury and you have the budget, you can go and translate your existing code into Scala. There is a very interesting blog which shows how to do that. So you have a reference here. Number 3 now, if you are not using Java MapReduce, right? You are using any of the tools. Our friend Pig, or Hive, or Scoop, or Cascading, or Crunch, or Mahout, or Mahal. So what you do in this case? What's happening now, that's why we are talking about transitioning, every single one of these tools is being ported to run on top of Spark. Now let's go see one by one. If you pick Pig, there is something which is called Pig on Spark. So you can call it Spark. So strange, right? So yeah, I know that you will discover a lot of things, but maybe you never heard about it. With all modesty, this talk is the first of its kind, which is talking about this transition and the how, way, not why, from Hadoop MapReduce to Spark. So now when it comes to Pig, there is Pig on Spark. So basically the design is the following, that you are simply adding that option. You are running your script, so you will pass Spark option. And you don't need to change your code. I won't say too good to be true, but they are almost there. Because I checked the design and checked even the Jira. They already passed 100% of all of the test case. So this is serious. So in no time, we'll be able to just go to our existing Pig scripts and just change the configuration. And voila, as we said in French, I do speak French by the way, voila, your script now runs on Spark and you can gain performance. And it's also the other way. Maybe somebody actually from the Spark world, right, wants to use Pig, this will be possible too. So there is in every single tool, I will put the umbrella Jira, which is available for you to go check and see when it's available. Now Hive on Spark, a lot of people are waiting that. This is big actually. And it's expected to be available in Hive 1.1.0. Recently they changed the version number. They are not going by 0.13, 0.14, whatever. Now they start with 1. I think it's mature. And soon in 1.1.0 we'll be having Hive on Spark. Same thing here. So all you have to do, set Hive execution dot engine equals Spark. That's basically it. You don't need to change your code. So it's configuration based. So that's basically it. So that's kind of like how you do it. Again, here there is the Hive on Spark umbrella Jira. You can check it, and it's still status open. QA 2015. So soon you will have you will see this available. Any question, please? So we saw so far 2 main tools of the Hadoop ecosystem, Pig and Hive, that you can use them, continue using your code. By flipping the configuration, you can run it on Spark. So now when it comes to Scoop, from technical perspective, I think somebody needs to convince me why you need to port Scoop to Spark, because if you understand how Scoop works, you are basically doing 2 calls, right? You are checking metadata, right? And then you are spinning whatever for mapper. I don't know how much actually performance will gain here. But anyway, for the purpose of trying to be exhaustive here, I'm showing that there is also a project or Jira for the supporting Scoop on Spark or porting Scoop to run on Spark. Now, cascading, is there anybody familiar with cascading in the audience? Yeah, there is few of them. Obviously, that's kind of like, remember in our big data stack? So that was at the application, right? First. So that's kind of like, it makes it easier actually to build your big data application. The good news that cascading will soon, in version 3.1, be ported to run on Spark. It's already running, cascading is already running on Tez, which is interesting. Pig already runs on Tez, and Hive already runs on Tez. And cascading already runs on Tez. That's what's interesting. So people already moved away from MapReduce, but maybe you weren't aware of that. So under the hood, the code is not running on MapReduce. It's running on Tez for specific Hadoop distribution. Apache Crunch, although it's not used by many Hadoop distributions or supported, it already moved to or already ported to run on Spark through the what is Spark pipeline class. So this is Java library. You have an example of running Crunch with Spark. Mahout or Mahout. This is interesting. If you go to the Mahout website, and this tool for a long time, since 2009. That's all you have in the Hadoop ecosystem, right? When it comes almost, right? Open source, I mean, for your machine learning type of things. On April 25th, 2014, I copied as it is. Goodbye MapReduce. Apache Mahout, the original Mahout learning ML, library for Hadoop, and this is available out there. Huh? Is rejecting new MapReduce algorithm implementation. But guess what? Since April 25th, so we did not see something available like 1.0. So this is still snapshot. That's why here you have an example. You will see some code already available. But I will say it publicly here. I'm still wondering why this project, Mahout or Mahout, maybe it's a good idea that it can combine with whatever MLlib from Spark and they join forces. I don't know, actually, maybe they have their own reason of going their own route. But anyway, Mahout or Mahout is already not using MapReduce anymore. All the new algorithm or existing algorithm are being ported to run on Spark. And also, they are also supporting an interactive editor in a la R, so like R. So we are done with this transition. Now when it comes to integration also, so evolution, we said how we moved from MapReduce, right, to Tez, to Spark, to Flink. That's my own opinion, right, in the future. Transition, we saw how if you have an existing Apache MapReduce application, how you can migrate it to run on Spark if it's in Java world, or if you are using one of the tools, Hive-Peak, or if you are using one of the application, be it Cascading or Crunch or Mahout. Now when it comes to integration, I think this diagram summarizes it all. So we will spend some time on it, and you will see that later when we go slide by slide, we will speed up on that one, because it's mainly for your convenience, so you can have something to reference, right? Because there is nothing out there so far which is summarizing or did that work yet. So we are proud to do it. When it comes to integration, so if you take that storage, or this may become also the serving layer, and do remember your big data stack from the beginning, right? Remember that was my contract between you and me, right? I said, stare on this diagram, think about it, give it some time, and now we will use it all the time. So HDFS obviously is integrated with Spark. Remember our talk here is on the transition from MapReduce to Spark, right? So we will continue focusing until the end of this talk on only Spark. We are not talking about Apache Flink or any other thing, or Tez or something. So we are just focusing on this integration, for example, in this section. Apache HBase obviously integrates with Spark, Cassandra, MongoDB. So these NoSQL databases, right? They all are integrated with Spark, and HDFS is integrated with Spark, and that was your bottom layer. Remember that? So that's what it is. And still in your bottom layer, right? I'm talking about the big data stack. The format, the JSON, Parquet, Avro, Kite, so they are all also supported in Apache Spark. So this is good news for you, because I'm sure you are familiar already with all of these, and it won't be difficult for you to continue using them. Kafka, remember that was in the streams, still in the lower layer of the big data stack, but that was, we said, we have the databases, right? We have the file storage, and we have the streams, right? Kafka and Flumes also integrate or are integrated with Spark, and they are integrated out of the box. Resource management, Yarn is integrated with Spark, but my take on this one, this still needs to be more mature, and there still needs to be some enhancement on that. Search, so you can consider this as other application. Remember in our layer, we said scripting language and application, right? Elasticsearch and Solr. See, imagine like you are indexing is an application, right? They are also integrated with Spark. Hive and the Deal, so maybe this may make Jim happy to hear that. So, but it's not there yet, so it's in the working that Drill will work with Spark. Hive, as we will show, it's already integrated with Spark. So basically, so we are focusing here more on open source, right? We are not talking about BI tools from the industry, from commercial tools or something, but just we are sticking with open source. So as you see on, yes, please.
For the data format, right? How about the Google Buffer data format? Is it integrated already, or
Which one?
Google Buffer?
Yeah, I did
Google
not.
Buffer.
Yeah, I did not check that. Yeah.
Repeat the question,
Please, sure.
The question is like a Google protocol buffer for data format.
Said protocol buffer. Is it already integrated? I said I did not check. That was my. I will take note. Yeah, I'll check that. I expect the answer to be yes, but I need to check. So most of the, so to make it easy, actually, most of the, whatever you are familiar with in the Hadoop ecosystem is integrated with Spark. Very simple. If it's not there, it's getting so simple. So everything which you are familiar with. So not just the tools, but every other actually layer, as you say, you are seeing here. We are talking about the storage layer, we are talking about the search, we are talking about data ingestion service, whatever, everything is. So I won't go into details every single one, right? I will pick few like randomly. So when it comes to HDFS, what does it mean that HDFS already integrates with Spark? So this means that Spark can actually read and write files from HDFS or files which are compatible with the Hadoop API. So it can be Cassandra, it can be Amazon S3, whatever. Something interesting, so this is what you have so far, but also what's coming in the near future, that also will have support for caching. And also there is something which is not really in the near future, but something kind of like almost like wish to have. Something new is called the DDM, Discardable Distributed Memory. This is a new concept in HDFS. So the idea is that you can have now data like in memory, which can be shared across jobs basically. So this is the vision, not yet dead. I put it here for so that you can see things are evolving, and but at least for the basic support if the HDFS is there. Now when it comes to Apache HBase, yeah, obviously I researched this, and there is I found out like mainly either you use the native Hadoop API or you can use a tool. So this doesn't come actually supported out of the box from Spark, but it's supported through the Hadoop API, and there is a connector, Spark HBase connector. Maybe later. So for Spark HBase connector, why I'm researching that, I did reach out to the author of this tool and invited him to add his tool to spark-package.org. This is interesting. So there is many things which are supported out of the box by Spark. Other things which are not supported, they are available in this website, again, spark-packages.org. So you'll find this connector, for example, Avro Spark integration. You can find also Cassandra Spark connector. You can find Spark HBase connector, etc. Cassandra is interesting. Actually here, I think, in my humble opinion, that's the most mature integration when it comes to NoSQL database. Very mature integration with Apache Spark, very advanced also. And while analyzing what's there in the market, I'm seeing actually a lot of adoption for having building application which are involving Spark and Cassandra. Maybe the beauty of this one is you can bypass Hadoop altogether. We don't need Hadoop. You can use the Cassandra file system, and here we go. And again, I'm seeing this for specific cases, right? So let's say, I gave here an example, but there is plenty of example on my own website. This is shameless plug, sparkbigdata.com, which is basically non-commercial. It's only a collection of resources about Spark and the integration with Spark. There is over 3,000 resources out there, and you are welcome to go visit it, and it's free access, and you can find tutorial, blogs, presentation, whatever you name it, and it's the most complete exhaustive collection of web resources related to Spark out there. MongoDB also does integrate with Spark, and you know what? Think about it this way, actually. Either you have a native integration, right? Native integration, which means something already Spark support, or you get this integration through Hadoop, because already Spark integrates with Hadoop. So that's the pattern. Very, very easy. For example, here when it comes to MongoDB, there is already Mongo Hadoop connector. So you can go and use this existing connector when you are reading and writing data. MongoDB reading and writing to MongoDB. You have a Spark application and you need to read or write data from MongoDB. You can just leverage the existing Mongo Hadoop connector. Obviously, a native connector will be better because it will be built on knowing the internal of MongoDB, and it will have better performance. For example, Spark, Cassandra did that. MongoDB, there is experimental actually, and they put here to encourage whoever did that. I'm not naming him here. Native Spark MongoDB connector. So he created this project. He cannot commit 100% to it, but he's inviting people who are interested from the open source community to help and build that native connector. So this way you can have something similar to Cassandra. Now here, this may be in trouble of saying that. So the integration with Yarn is still improving. So it doesn't mean that there is no integration, no. Since Spark 06, there is already integration. Now Spark is at 1.2, right? But still, it's not like fully baked and still needs improvement. Check this on your own when you have the slides of this presentation. Click on that link, and I'm claiming that there is some critical issue out there that still need to be fixed. And some of them are like lagging for months unfixed. So hopefully whoever will hear this presentation or see these slides, they can do a better job of going and fixing these bugs. Because we are saying that we as technical people, we can go to Jira and we can write a simple query and check the status of the bugs when it comes to something as fundamental as Yarn, because that's a fundamental piece, right? To have your application run on or use this resource negotiator. Anyway, you have another option, which is Mesos, which is more mature, and that's the one which was built in this BDAS, Berkeley Data Analytics stack from originally. Originally, Spark was built to run on Mesos, not on Yarn. So Yarn comes later, right? And that's still not mature as Mesos. So that's the other option. Yeah, obviously, if you are using Cassandra, you don't need either one of them. When it comes now to Hive, so obviously there is a built-in support for Hive tables. So this means from Spark SQL you can read Hive tables. I put here a note on the ORC file because they don't have logo. All the other format they do have, so that's why we end up adding this one. When it comes to drill, the plan is for 2015 to support, to integrate drill with Spark, and they have the link out there for your convenience, so you can go and check it out. Now, Kafka, remember in our big data stack diagram, that first diagram, so we put streams in the lower stack, and this integrates out of the box with Spark. Obviously, they do have interest in doing that, because for Spark streaming, you need that you need Kafka to get that streams before you start processing them. There is an excellent tutorial out there that you can go, and it shows, explains step by step the integration between Kafka and Spark. Flume also integrates natively with the Spark, and I have the details on that. Your JSON, I'm sure this is a popular format, and I'm sure many of you are using it. So the good news that it's natively supported by Spark, and they have also something which is very interesting, to tell you the truth, actually. I will read it. Spark SQL can automatically write, let me go back, can automatically infer the schema of a JSON dataset. This is really beautiful. So that's basically something which we are not used to see. So that's kind of like this report is outstanding. You just point your Spark SQL to JSON file and you query it. That's basically it. So you don't need actually to know more DDL, know nothing. So that's automatically, it will read your file, it will infer the schema. So you don't need to do anything in particular. So Parquet is also another popular format, and it's showing that it's helping a lot when it comes to performance. And this is also have built-in support in Spark, and I'm showing you the details. Avro also is supported by Spark. For your convenience here, I'm giving an example code, how to do that, and also use case showing how it's used in real life. Kite, maybe not many of you are familiar, but I tried to be exhaustive to show all what is supported, right? Although only particular vendor is supporting this Kite SDK, but anyway, this one is does integrate with Spark. Elasticsearch also does integrate with the Spark, and I'm showing different type of integration, different tools, different ways, and also use case. Solar also for researching your data, indexing it, does integrate with the Spark. How many of you are familiar or using Hue? Yeah, good number, right? So don't worry, you won't be missing Hue, right? Well, if you move to Spark, because Hue already integrates with Spark and does support Spark. Although, in my humble opinion, it's still like a simplistic way of doing it, but anyway, it integrates. That's my take on that, and it's called Hue Spark Igniter. So if you put that latest version, you will see that you can use a graphical interface to integrate with Spark. Now, when it comes to alternatives, yeah, so similar to what we did in all the other sections, we will start with a diagram or with a table which shows us everything, and then we can dig. So here, so if you consider the Hadoop ecosystem to your left, right? So you have, when it comes to component, HDFS, YARN, right? When it comes to tools, Peak, Hive, Mahout or Mahout, Storm, Giraffe, Hue, right? Stands for Hadoop User Experience. So to your right now. So HDFS, you have its counterpart on the Spark ecosystem. By the way, that ecosystem, or that started, as I said, BDAS, right? Berkeley data analytics stack, right? But now it's turning to Spark ecosystem. So there is something alternative which is called the Tachyon. How many of you ever heard about Tachyon? Yeah, interesting. Yeah, interesting. So this is part of the Spark ecosystem, and I will show later what it is and how it's used, right? Mesos also, it's something which is, you know, maybe it's a brief actually parenthesis. You know what was created first? Wasn't Spark and then Star, and then Mesos. Originally, Mesos was created first as part of kind of like almost like a project in a course in University of Berkeley. So it's an assignment. The assignment was to create something which now turned to be Mesos, and it becomes big in the industry. As simple as this. And now later, after they created this resource management tool, they said, let's find or let's build an application to run on this resource management tool. And that's how Spark was created. It was created as an application to run on Mesos. But what you see in the marketing is completely different. They will tell you, you know what, we were using, sorry, I take responsibility for that. We were using Apache MapReduce, and we figure out that it's not good for machine learning algorithm, and then we created Spark. No, that's not how it happened. So if somebody finds out this is incorrect, you have my email, sbartage@gmail.com. Send me your side of the story. But I can tell you exactly, I have my reference, as I having over 3,000 web resources dedicated to Spark. I know every single thing, almost about history or whatever, these resources. So this is exactly what happened actually. Mesos were created first as an assignment in a course at the UC Berkeley. Spark was created as an application to run on top of Mesos. That's not the other way, or that's not was created because Hadoop MapReduce was slow and not suitable for machine learning algorithm. So when it comes to tools, Peak, the alternative for Peak in the Spark ecosystem is Spark Native API. This is robust because these guys already have over 80 operators, right? So you don't need actually, it's almost, maybe somebody can bring some water, please. Yeah, yes. Some water, please. Yeah, mine is the exam. Thank you. So anyway, so that's when it comes to Peak. When it comes to Hive, you have its alternative as Spark SQL, Mahout, as alternative MLlib, so machine learning library. Storm, as you mentioned earlier, you have a Spark streaming. Here, it's not really an alternative because they are not in the same category, right? Storm is for real time, right? Spark streaming for near real time. So for specific use case, it might be easier actually to do that switch if you have a reason for that. Especially if it's easier to code, you don't need to think lower level as in Storm, and you can have unified data flow. You can use Spark streaming with other tools. Giraffe has its alternative as GraphX. Hue has its alternative as Spark, Notebook, and iSpark. It is even more powerful than Hue, and you will see that in the example. So we mentioned that Tachyon is distributed in memory file system. So for specific use cases, or even you can accelerate HDFS by using Tachyon. So it's, as I'm saying here, this came as the storage layer for the Berkeley data analytics stack. So that was their own storage layer, but it's 100% in memory. Mesos here is still Jim in the audience here. Jim Scott, or he already left. Yeah. So if he's not here, maybe shout to him. He will be actually, he already had something available actually on the web, which is a walkthrough of Yarn versus Mesos. So thanks a lot. So this is our very own Jim Scott, who have that. So I think actually I have a reference to what he talked about and explaining the differences and when Yarn what are kind like pro and cons versus Mesos. Okay. Here, although this is not really very honest when you show something like that, but it's a way of showing that Spark MLlib is actually there is a growing interest, right? Obviously, going to Google and just using Google Trends is not the only way or the scientific way of showing that the tool is picking up, but at least it shows actually that indeed actually Spark MLlib is picking up, and there is a lot of people who are actually writing algorithm and contributing to this project versus Mahout. This is a reality. Here, as I'm saying, Storm and Spark streaming definitely depends on your use case. With the Storm, you can have a real low latency, which you cannot have with Spark streaming, because as Jim was saying, you have windows, let's say 5 seconds. It's not really real time, it's near real time, if you can say that, but it fits in many of the use cases. I show here in a tabular format the Storm versus Spark streaming. I won't be reading that to you. This is for your own convenience, so you can check it at your own pace. But the main things that you need to have in mind when they bring one versus the other is that one is processed one record at a time, that's Storm, while Spark is mini batch. And the latency, the sub-seconds for Storm, and it's few seconds for Spark streaming. We are not saying here one is better than the other, or it's just what are the features of it. So this way, when you are picking one versus the other, you know what they are. It's a tool at the end, right? So it depends on your requirement. Same here, we are seeing an update when it comes to GraphX as an alternative to Giraffe. As I mentioned before, for Hue, in the Spark world or on the Spark ecosystem, you have 3 tools. So basically, these are really very powerful. And for those of you who are interested to learn Spark, Spark comes already with a shell, right? Either you are using Scala or using Python, right? But still, you can use even more powerful tool. So you don't need to. I mean, if you are fine with the shell, it's already enough. It's compared to MapReduce time, right? Writing this in Java. It's already easier, it's already user-friendly and everything. But here, what I'm saying here, already there is something, these notebooks in the Spark ecosystem, which is make it even easier. So you can share your code, and you can run your code in the web browser. It's very beautiful. And there is three of them. The Zeppelin and the Spark Notebook, they all support Scala, while the iSpark, they can support Python. I have links to the tools, and do remember what I said, when it comes to learning Spark, just as friendly advice, using this tool will make it even much easier. So far we talked about the evolution, right? From Apache MapReduce to Tez to Spark to Flink. We talked about transition. If you have an existing Apache MapReduce project, how you can migrate it to Spark. We talked about integration. If you already invested in tools or you are familiar with tools from the Hadoop ecosystem, you can actually see, you will find out most of them are either natively supported by Spark, or you have third-party tools, open source and free, which allows you that integration. We saw the alternatives, right? So it depends on your use case. You might be able to swap a component, as we saw example, right? When it comes to Storm, if you have really need low latency, Storm is the way to go. If your use case, you can use batch, like Windows, you can use Spark streaming for some good reason as well. Now, complementarities, it's, as I said it in the beginning, it's not always like either or, right? Because that's what you will read in the news, that's what you will read sometimes even in other presentations or talks, really. So it's kind of this one, this is, in my humble opinion, this is a binary way of thinking, when you say either this one or the way, either 1 or 0. In real life, it's most of the things that they are not binary. Machines are binary, 1 or 0. Most of the time, we are thinking like actually more in type of fuzzy way of thinking, right? So it's kind of like more between 0 and 1, pick a value. So here, same thing here. When it comes to the tools, there is a complementarity between the tools. I picked that diagram. It has nothing to do about religion or culture or something. I like it as it represents like integration. Definitely, you can use Tez and Spark altogether. Maybe surprised, right? Because so far we were seeing like evolution, right? From MapReduce to Tez to Spark to Flink, right? Indeed, you can use Tez and Spark together, and they will show all the details, but I will give you a reference on that. And there is a reason for that, especially when it comes to ETL. So you can actually port Spark to run on Tez for like a huge and large data sets. It was very tough for me to find a logo for Yarn, but that's the one that represents Yarn, by the way. So, that's the one, Yarn to the left, and then your Mesos. And the other one is HDFS and Tachyon. I think by now you already have a high-level idea about what's Tachyon, right? So it's your distributed in-memory file system, right? Your Mesos is already another resource management, which is, Yarn is more tied to Hadoop, right? While Yarn, as you will see, supports much more services and much more application. And Tez is very actually tied to Yarn itself, but you will see that it can work with Spark, and there is a reason for that. So for me, that's what I mean by complementary, right? Complementarity. So you can pick, you can use them together. Obviously, it adds complexity, right? For maintenance and for, but hopefully this vendor can take this complexity out from us. I won't name a vendor actually, but I already, while researching this, I saw somebody who is doing something very clever actually. I cannot actually say the name. They're not even paying me to say that. So they created a kind of like a layer on top of, so this means what? When you are running like a job, automatically based on your data set and based on other parameters, it will just channel it to one of the tools. How beautiful is that, right? So it's doing MapReduce, Steep, or Tez, or Spark. So maybe you can research that as a quiz and try to figure out. It won't be easy actually. It's kind of like you need to dig under the hood and figure out who is doing that. It's actually a vendor in the commercial vendor in the BI BI section of the big data world. So hopefully it gives some hint. Yeah, so it's clever. So maybe the industry will follow, and we may end up saying something like this, like a layer when you can actually base it on the load, and just channel it one of the other. Because at the end, it's libraries, right? You can have them part of your stack, and you can do that. So here, HDFS and Tachyon, I have a couple of links out there which are showing how they can work together. Same thing for Mesos and Yarn. There is even an upcoming talk in the Hadoop Summit, which will touch on that. And I think what the industry is figuring out, there is really, in this specific case, Yarn and Mesos working together is something which is really needed. It's not just a luxury, really. So I invite you to take a look at the couple references that I put out there. And one of them, as I said it earlier, the first one, Apache Mesos versus Apache Hadoop Yarn. So that's our very own Jim Scott who did that. And it's available on YouTube, you can check it, right? So he's not giving me another slice of pizza or anything. It's just I'm volunteering to share this information. Yeah. So when it comes, as I said it earlier, right? Tez and Spark can work together, right? So for efficient ETL, so for a specific workload, and because Tez have very good integration with Yarn, knows better actually the Hadoop, the inner workings, and also supports security and other features. Now I get to my takeaways. So I'm respecting your time. We still finish this in 2 minutes and open it to more questions. We try to make it interactive. That's why from time to time I ask you if you have any question. So remember, we started this in our agenda, right? Evolution, transition, integration, alternatives, and complementarity, right? So this is my own, what I think, key takeaways. Your takeaways may be different, right? So that's open it for discussion. So for me, the evolution of the compute models is still ongoing. So Spark is not the end of the world. Keep watching other tools, and you will figure out that they might be fixing a problem. And so I know that we go by period of like hype and marketing fluff, but that's from technical perspective. Just I invite you to look at that. From a hard web, when it comes to transition, as we saw, most of these tools, right? We name it hype, right? Peak, scoop, cascading, crunch. None of them is already ready, right? When it comes to being ported to Spark. I did provide Jira for each one of them, so keep looking. And once you are ready to migrate or adopt Apache Spark, so you can see that. When it comes to the alternatives, do your own due diligence, right? So forget about the marketing, forget about what the vendor are claiming. You can figure out actually what the tool is good at, and I know that all of us, most of us, we are doing that already. When it comes to complementarity, I know this is a very difficult, actually, maybe topic, and indeed, there is a reason for specific cases we need to use both. It's not like either or. Yeah, with this, actually, with this, I'm done with my talk, and I invite you to ask a question. Yes?
What is the prime reason to run Spark on top of the Cassandra? What was the main use case? Why would you do this?
Yeah, exactly. Yeah, very interesting question, actually. Yeah, you know, actually, for this kind of like Internet of Things, right? And especially Cassandra is very good at storing this type of data, right? And now you bypass HDFS because HDFS is the bottleneck in this case, right? I'm not generalizing. So in this case, the combination of Spark with Cassandra is really like how they call it, marriage in heaven, right? They are not paying me, I say it again to say that. But for this specific use case, you cannot beat that, right? So maybe somebody doesn't agree with me, but indeed, they do have. Plus the other thing that they have, like cross-center replication. They don't need zookeeper, you name it, right? So there is this specific actually niche, and it looks like they are actually making some progress in that direction. Yes, please. Yes, please.
Related question, is Spark aware of the data locality when it's connecting to or sourcing from Cassandra?
Is Cassandra, or what was the question? Can you repeat?
So when using Spark for processing data from Cassandra,
Yes.
is Spark aware of the data locality on Cassandra nodes?
No, actually, I myself don't have experience in that, but I need to research this one. But all I know, maybe somebody can answer. Yes, please.
I can answer, yes, it does.
Oh, excellent, excellent,
It does.
excellent.
So but you really got to pay attention to like Cassandra sourcing, read data.
Excellent.
It's not just like just run it. It's like it's going to start swinging that. You got to do data. It is data partition.
Yeah, but the idea that you are, in this case, you are bypassing Hadoop altogether. Yes, please.
So if in real time there is like a count which is going up and down, so would Spark streaming be an application that we could use?
So could you please repeat your question?
So if in real time there is like a count of
Yes.
events which is going up or down,
Yes?
so could Spark streaming be used in that case?
A count going up and down.
Yes, or count of events going up or down, like it's increasing or decreasing, and in real time. So can Spark streaming take care of that?
Yeah, Spark streaming is not for real time, right?
It's not?
No, it's not.
So that's not a
Yeah, Spark. Yeah. So in your, if you need low latency, right? So Spark streaming is not the right one. And we have an expert here. He will be presenting on the different. Right? Correct me if I'm wrong. Right? We'll be presenting in the Hadoop Summit, if I'm not you, Jim, right? Yeah. You will be presenting on the different streaming.
Yeah. In general streaming, yes, I actually will be
exactly.
presenting at Strata.
Yeah.
What would
Strata.
you use in that case?
Well, Storm will actually handle event-based
Exactly.
streaming.
Okay.
So as a message comes in, it's processed. I think this was something we were talking about a little earlier, is that when you have Storm with Trident and when you have Spark streaming, is they're actually operating on batches. So you're not getting true real time.
Exactly.
Still going to be fast, still going to happen pretty close to real time, but it's not. So it depends on what you're actually looking for in that use case.
Actually, I have a related question. So, like the Trident in Storm, this is also mini batch, right? So how do
Exactly.
you compare that with Spark streaming? I mean, they seems to
Well,
be
batch is batch is batch if you want to put it in that context,
okay.
right? Event-based versus batch.
Right.
So Storm, Trident would be roughly equivalent to Spark streaming
Okay.
in that model.
That's
And
the
it-
point. Yeah.
I'm just saying, is there pros and cons? You know, performance-wise.
Nope.
No.
We actually had a talk a couple months ago that Yahoo came in and did, talking about Storm versus Spark. We have that video posted on YouTube, so if you'd like to watch that, catch you up on it. I don't know anyone who has much preference one way or the other. Kind of pick one, test it, mess around with it, see how you like it.
Yeah, but definitely Storm is more mature, right? So that's. We have the problem here with who is supporting it, right? So far, yeah, we stop here. So not much actually company are supporting it, right? So that's the idea too. Yes.
No, Storm is supported, I think, by Quarter.
And also, I think Mapar are
Yeah,
supporting it.
Mapr does support it. I can't speak to the other vendors who does it. I know Cloudera does not.
No, Quarter works around it.
Yeah, I don't know if Hortonworks does or not. I know Cloudera does not.
Yeah,
I've actually heard people complain that they don't.
Storm,
Hortonworks does,
Yeah.
right?
What are the GPUs that does in terms of getting higher speed efficiency than Spark?
Yeah, maybe it's interesting. Actually, I did not research that, but maybe interesting to see if the combination now. The Spark with the GPU. With the